Good morning, guys. I hope you had a restful week at home. Okay, not having to jump up and worry about schoolwork. I hope everyone is safe and healthy. Um, I'm going to just review with you today some of the problems that we've done prior to going out, and then I'm going to give you a few problems to do. What's going to happen this week is we're going to do one or two more of the solving equations, and we're going to end the marking period with a little test. Okay, and that'll happen Thursday or Friday. So I just want to review. Remember the single functions, just rewriting these. Okay, some of you expressed that they were kind of fun, and I'm glad that you thought that. Okay, so it says express as a single function. All right, sine is just sine, but cotangent really is cosine over sine. And when I multiply that by the sine, what happens very nicely is the sines cancel out, and this is just cosine. Okay? Secant theta, 1 minus sine squared theta. I don't know how many of you remember, but this was one of the Pythagorean identities. You'll have it in your notes, okay? It's something you should recognize, that sine squared theta plus cosine squared theta equals 1, and then we were able to rewrite the problem. And so this really is the same thing as saying the cosine squared of theta, okay? Secant is really 1 over cosine theta. When I multiply these two together, one of the cosines will cancel out with one of their cosines, and again, you're just going to be left with cosine theta. All right, I see cosine's the big winner here. Okay, so tan theta times, notice how there's parentheses here. Now, you might want to first change these. This would be sine over cosine, cosine over sine, sine over cosine. But then you're multiplying fractions. I know how much you hate that. So what I suggest you do first is distribute as it is right now. If I distribute it right now, I'm left with the tan theta cotan theta plus tan times tan is tan squared theta. Now I'm going to change it. This is really going to be sine over cosine. This is really cosine over sine. And what happens very nicely here is everything cancels out, and basically it's 1 plus, I'm going to leave this for a second, as tan squared theta. Now, you should have your identity sheet next to you because this is an identity, okay, and it really equals secant squared theta, okay? So, yeah, you're going to have to review your identities. Just wanted to freshen that up in your head. Remember doing that. Okay, the other thing that we did before our so-called spring break, hold on, I'm going to put this in between so it doesn't bleed through, is we solved some trigonometric equations. All right, and let's see if you remember these. So my goal here is to get sine x alone. I'm going to add 1 to both sides. 2 sine x equals 1. Divide both sides by 2. Sine x equals 1/2. Okay, now what I want to do is I want to find the angle that has a sine of 1/2. You could have your little index card, your little cheat sheet with you. Okay, first of all, it's a positive 1/2. So I'm looking for the answer in quadrant 1 and quadrant 2. Okay, and the angle that gives me a sine of 1/2 is your 30-degree angle. I would like you to give me your answers in radian measure. So it's going to be pi over 6 in quadrant 1. And it's 5 pi over 6 in quadrant 2. And I know you guys are saying, oh, that's right, I forgot all this stuff. Yeah, it's going to take a while for you just to, like, remember it, because I'm sure you spent the whole week studying all this stuff. Okay, radical 3 tan x, I'm going to add 3 to both sides. Hey, what would have been a nice thing I should have told you from the beginning is you should have, seen if you could solve these on your own and then press play. Radical 3, divide by radical 3. I'm left with the tangent of x is equal to 3 over radical 3. What are we, savages? We don't leave radicals in the denominator. We'll multiply the numerator and the denominator by radical 3. and get 3 radical 3 over 3. The 3's cancel out, so I'm left with the tangent of x is equal to radical 3. Again, where is tangent positive? Tangent's positive here and here. Okay, so in quadrant 1, the angle that has a tangent of radical 3 is pi over 3. It's a 60-degree angle. And in quadrant 1, 2, 3, that's going to be 4 pi over 3. Okay, so that's your answer for that one. Okay, now this one's a little different. Okay, if you see, we have sine and tangent all mixed up and stuff. All right, we have two terms, this one and this one. All right, I'm not going to be able to solve it the way it is, but I notice that they both have sine in it. So what I'm going to do is I'm going to factor out the sine. Factor, just when you thought it was safe to turn on a video. Okay, so if I take sine out of both those terms, look what I'm left with. I have two different factors. I'm going to set them both equal to 0. Sine of x equals 0. Let's talk about this for a second. All right, this means when your sine or your cosine is 0 or 1, it's going to be one of your quadrantal angles, okay? Your sine is your y value, okay? Your y value, all right, happens at when you go to the right or to the left for 0, so it's going to happen at 0 degrees, and it's, wait, 1, you go over, yeah, up 0, and pi. Okay, and again, that should be on your index card. Over here, let's set this up. It's 2 tan x plus 2 radical 3 equals 0. I'm going to bring this over first. 2 tan x equals negative 2 radical 3. Divide by 2, divide by 2. Tangent of x is equal to negative radical 3. Oh, it's the same as here, only it's the negative now, whereas this up here was the positive. So we're not looking in quadrant 1 and 3, we're looking here and here. So we know the reference is pi over 3, so this would be 2 pi over 3. Oops, I forgot the pi. 2 pi over 3. And it's going to be in this quadrant, which is 5 pi over 3. Okay, I hope this sparks some memory in your head. I'm going to actually, I didn't type up your sheet, I just wrote your sheet. It's on the video, so here. This is your homework. Remember how to do your homework. Guys, just do this in your notebook, okay? You should be taking notes as you're watching the videos, just like we're in class, okay? The video basically is me up at the whiteboard, all right? And then do your homework in your notebook, snap a picture, and send it to me through Teams, okay? Don't try to type this stuff up. It's ridiculous trying to type it. Okay, so you have 4 problems expressing as a single function, okay? And you have 2 problems where you're going to solve and tell me the values of x between the intervals. I should have put the intervals between 0 and 2 pi. Okay, so that's your work. Like I said, we're just going to keep doing more problems like this. They're just going to get a little tougher. Okay, I'll show you how to do them, and that's how we're going to spend the rest of the week, the last week of the marking period. Guys, I hope everything is well with you and your families. If anything's going on and you want to talk to it, please reach out to me on Remind. If you even need me to give you a call, just send me a text and I'll give you a call. I hope everything is going well. I know this is not an ideal situation. I miss you guys desperately, and I'll talk to you again tomorrow.